Hello and welcome back to Programming from the Ground Up. Let's review what we've done so far. We've realized in the last few lectures that computers are simply machines that we can give simple instructions to, that we can write in this sort of special notation. Afterwards, we can transform those into ones and zeros, and then if we feed those into a computer, we can get the computer to do some sort of work for us. And in the last lecture, what we did was we applied that to calculate a large multiplication, or large for this processor, which was 35 times 47. And when you use and this was kind of like our first computer program for the imaginary computer we created. Now, when you use the instructions of the processor directly, as we did here, there's a special name for this, and what this is called is assembly programming. The assembly language means that you are taking the instructions of the processor as detailed in the processor specifications and using those to directly alter the memory of the processor and make it do the basic operations that it can do. However, this type of programming is incredibly tedious, as you may have noticed in the previous lesson. In order to multiply these two numbers, we had to do a lot of work. There was all these lines of code, and they were all kind of cryptic, which is a little bit rough. Usually, programs that you write are much more complex in nature, and can you, I don't know if you could imagine writing something like a web browser in these simple operations. It just doesn't really seem to make sense. So, what we do is we invent programming languages in order to solve that problem and allow us to express our higher level ideas and to write more complex programs and build them on top of each other. So in this lesson, we're going to look over how to reason about what a programming language really does. Let's go back to our previous example in the last lecture. If you remember, we didn't have enough room in our move instruction to move a number greater than 15 into a slot. So if I wanted to put the number 30 into S1, I would have to do this. I would have to say, okay, move 3 into S1, move 10 into S2, and then multiply S1 by S2 and store that back in S1. And this whole thing here, that would be how you move 30 into S1. But this is really tedious, and this is also pretty much the same no matter what. All I have to do is to move a number greater than 10 is multiply, the second digit by 10 and add the first digit. So in reality, if this is like a systematic thing that we can decompose into simple operations, why should we have to write out these instructions every single time? Let's say that we instead define another instruction called move large. And what the move large instruction will do, or it will look like, is we'll say, okay, so move a large value, 30, into S1, and then, because we can systematically decompose it into simpler operations, that will actually translate to these instructions into the when we input them into the processor. But and this already makes things a little bit easier, and this would have made this task much easier here because we wouldn't need to we wouldn't need to do all this decomposition step by step like we did here. All we would have to do is just call the move large instruction and then systematically expand every move large instruction into these smaller instructions. But this is still a little bit annoying because we have this S1 here, and we were lucky in the previous example because we only had 4 places where we could store information, but your current computer actually has about 1 billion places where you can store information. And do you really want to think, okay, so S1, it stores so some value here, and S 2000 stores maybe another value that I need somewhere. It gets a little hairy and a little bit confusing. So in order to solve this, let's say that instead of referring to the location where we store things directly, we just give it some sort of name. And then afterwards, when we're done writing our program, we can go in and replace those names. And I'll show you how that works. Let's do a very quick and simple example. Let's say I have a program that computes the area of a rectangle. And as you know from elementary school, the area of a rectangle is equal to the width times the length. Now, if we were to write it like we did in the previous example with the raw instructions of the processor, we would have to say, okay, so the width is gonna, so let's say, okay, width is gonna be stored in S1, and length is gonna be stored in S2, and area is gonna be stored in S3. And throughout the course of writing our program, we're gonna have to remember all of that. And then if width is greater than 15, then we're going to have to do, we can't just move the width value straight into S1, we have to do some crazy stuff. So let's just say we're going to use this move large instruction that we've just defined. So we're going to move large, let's say for this example width equals 30 and length equals 40. We're going to move large 30. And instead of saying S1, which is what we want, we're just going to say we're going to move it into width. It doesn't really matter what width is, as long as we can easily retrieve it and modify it. And hopefully you'll see what I mean in a bit when I finish writing this program. So I'm going to move L 30 into width, then I'm going to move large 40 into length, and then I'm going to multiply width times length and store that into area. And now this program here is actually not very not that difficult to understand compared to if I had to write this program with the raw instructions. And this is kind of what we want as programmers. We want to be able to understand what we write because we're going to be writing a lot of code at some point. Now, after I write my program like this, I can pass through this entire program, if it was bigger, if it was smaller, and then I just say, okay, so width is actually going to be S1, length is going to be S2, and area is going to be S3, and I just go through this, through my program. And every time I see width, length, or area, I just make the proper replacement, and then I convert the move large instructions into the smaller instructions that the computer understands, and then I convert those instructions to the ones and zeros that will go into the processor. So essentially, this has allowed us to be more expressive in what we actually want the program to do, such that we can read it and understand it later. But this is still not exactly, but this still isn't that readable, and we can even go further. Let's say I don't like the move L instruction, and I want to kind of go away from the notion of instructions in general, and I just want to be able to say width equals 30, and length equals 40, and area is equal to width times length. And then we can go through the process of converting each of these, or this series of statements, into this. So first we say, okay, so like the equal sign just means that we are assigning a value of 30 into our variable width, which is exactly what we do here. We just call it width. And then we do the same thing for length and the same thing for area. We just say area equals width times length. And afterwards, after we convert to that, then we pass through and put our S1s and our S2s and our S3s where we actually want to store them. And then, just as before, we go, okay, we convert the move large instructions into the primitive move instructions and multiply instructions that we needed in order to move large numbers into our memory locations. And then again, we put it through, we encode them in ones and zeros, which again goes into the computer. So this here is an example of a simple programming language. This allows us to express the actual ideas of our program without tediously worrying about every single instruction and how we're going to use the instructions of the processor, because it's a very systematic and simple job, and that means that it can be done by a computer. So in the next lecture, what we're going to do is we're going to talk about the program that actually does this kind of conversion of programming language to basically the ones and zeros of the instruction. And hopefully you'll join us for that, because that's really fun. Anyways, thank you for listening. I'll see you next time.